Hello everyone and welcome. In this video sponsored by Advanced Auto Parts, we are going to be looking at various types of fuel injection technology. Starting with some old school stuff, here we've got some carburetors, we're going to move on to port injection and then end up with direct injection. And so we're going to be talking about how these all work and what are the advantages and disadvantages of each. And we're also going to be looking at some modern engines are actually using both port and direct injection, so why might they be doing that? First off, a big thank you to Advanced Auto Parts, who has supplied all of the fuel injection related parts for this video. Of course, check out their website linked in the video description for any car part needs you may have. Now, while they go about doing it in very different ways, everything in front of me here has the same basic goal, and that's to put some fuel in the engine. Along with that fuel, it will mix with some air, have little explosions occur inside of that engine, which will help move your car forward. The important part, of course, is making sure that you have the right amount of fuel with the right amount of air. That ratio is very important. So let's start off with our most basic form of fuel injection, and that is carburetors. Now, carburetors haven't been used in production cars for decades. However, they were still being used in NASCAR as late as the 2011 season. And while they are very limited in how much control they offer, they do actually have a few advantages. Now, looking at a carburetor, it looks rather complicated, but the basic principles of how it works are actually really simple. And so it all surrounds the Venturi effect. So what we're looking at here is if you have air passing through a pathway and then you restrict that pathway, it causes two things to happen to that air. The air velocity speeds up and the air pressure drops. What a carburetor does is it takes advantage of that pressure drop in order to inject fuel. So here we're looking at a cutaway of a carburetor, and we have this fuel reservoir over here to the side, and this fuel reservoir is exposed to two different pressures. Atmospheric pressure before the carburetor, your air is going to be flowing in from up top and then down. And then you also have the injection nozzle right here, which is also exposed to the pressure within the carburetor. So as you have that high pressure air then decrease in pressure, that means you're going to have a higher pressure pushing down on that fuel and forcing the fuel within this injection nozzle to come inside of the carburetor, move past your throttle, and go into your engine. Now, the more you open this throttle, the more airflow you have coming through, and thus you're increasing your pressure differential and you inject more fuel to make more power. So that's the basic principle of how this carburetor works. So on the carburetor itself, you'll see two valves. Here we have the throttle valve, which is ultimately what the gas pedal is controlling. So when you floor it, you open this valve up all the way, which allows for maximum airflow through the carburetor and thus maximum power. On the entrance side of the carburetor, there's another valve, the choke, which is used for cold starts. So the choke is used to close off the entrance to your carburetor. So by closing off that entrance, what you do is you create a really strong vacuum within the carburetor when you're trying to start the car. Because the engine is pulling the piston down, it's trying to pull in air and fuel, and in doing so it creates a strong vacuum within this carburetor. And so you have a strong vacuum on one side, you've got atmospheric pressure on the other, so it dumps in a lot of fuel. And because your engine is cold, you need more fuel than usual because not all of that fuel vaporizes to help start the engine. So you inject more fuel so that you have some of that fuel vaporize so that you can get the engine going. And then once things start to warm up, you can open up that choke completely and the engine runs like normal. So the beauty of a carburetor is its mechanical simplicity. It sees more air going into the engine, so it injects more fuel. So let's say you were to modify your engine so that it's now better breathing. Well, the carburetor simply sees more air going in, so it injects more fuel. Now, there's also a bit of a downside to its mechanical simplicity because you really don't have much control over that air-fuel ratio. Now, you can have multiple barrels within a single carburetor. So here you see a single barrel carb, and then here we have a 4-barrel. And what this allows you to do is operate in stages. And so instead of just having one constant that has to maintain that air-fuel ratio for all of your engine RPM, instead you can tune things a bit differently so that when you're at lower RPM, you're just opening up these two smaller barrels, and then once you get up into a high RPM and you need maximum fuel flow and maximum airflow, you can open up all 4. And that will allow you to have a better range of air-fuel ratios that help the engine run smoother throughout its RPM regions. So ultimately, carburetors are simple, they're cost-effective, they're mechanical systems, but they don't have that much flexibility with air-fuel ratios, which is what sent everyone switching over to electronic fuel injection. So now let's talk about port fuel injection. So ultimately, that gas, of course, comes from your gas tank, passes through a series of pumps and filters, and makes its way to the port fuel injector, which sprays that fuel in before the intake valve within the intake manifold. And so that air and fuel actually starts to mix before it actually enters the cylinder. Now, some of the earlier fuel injection designs actually had the injectors right at the throttle body. However, the disadvantage here was that it actually had varying air-fuel ratios across the different cylinders. So typically what you'll see today is at least one individual injector for each individual cylinder so you can directly control the amount of fuel going into that cylinder. So here you can see the 8 fuel injectors for a V8 engine, and so each of those injectors will be placed so that it sprays a fine mist of fuel into that intake port. The intake valve opens, of course, allowing that air and fuel mixture to come in, being pulled down by the piston. Then it compresses, still mixing that air and fuel, and then you have your spark ignite to create power. So the big advantage of port injection is you have control over timing and how much fuel you're actually going to inject. So for example, if you want to make lots of power, well, you'll run a rich air-fuel mixture, meaning you have excess fuel. And you do this for 2 reasons. First of all, by dumping in that excess fuel, it ensures you're really going to get most of that oxygen within the cylinder burned, so you're going to make as much power as possible. But also, there's a cooling effect to injecting that fuel in. And so when the fuel is injected and it vaporizes, it cools that intake charge. So you can actually pull in more air and fuel into that cylinder and thus make more power. Now, on the other hand, if efficiency is your goal, then you're not going to run that super rich air-fuel mixture. You're going to lean it out a bit. And so, regardless of whether you're at idle or mid-throttle or full throttle, high engine RPM, low engine RPM, electronic fuel injection is going to give you control over how that air-fuel ratio changes depending on how your scenario changes and what you're asking from the engine. Another advantage of port fuel injection versus direct injection is that the fuel can help clean your intake valves. Gasoline will have additives in it to help remove and help prevent carbon deposits so that as fuel is sprayed in the manifold, some of it will hit the intake valves and help keep them clean. So versus direct injection, packaging, cost, and the amount of time that the air and fuel has to mix are all advantages. However, going back to air-fuel ratios, because that fuel is sprayed into the intake port, some of that fuel ends up on the walls, and that can actually influence your air-fuel ratios depending on the scenario. So it's something that has to be taken into consideration, and it's a bit of a disadvantage versus direct injection. So finally, we get to direct injection, and as the name implies, these spray fuel directly into your engine cylinders. Now, where a port injector may spray that fuel into the ports at maybe 40 to 90 psi, direct injection used in gasoline engines will spray in the fuel at 1500 to 5000 psi. So there's a couple reasons why you want to use those higher pressures with direct injection. First being that you want to have that mist as fine as possible. So with a port injection engine, there's plenty of time for that air and fuel to mix. With direct injection, it's going right in during the intake stroke, so you've got less time for that air and fuel to mix. So you want it to be sprayed out as fine as possible so that it mixes as quickly as possible. You also want to spread it out as much as possible within that cylinder. So by using really high pressures, you can spread that fuel out nicely throughout the cylinder. Now, one of the major benefits of having that fuel injected directly into the cylinder is that it cools directly in the cylinder. So as that fuel changes from a liquid to a vapor, that vaporization causes a cooling effect. So you have lower temperatures within this cylinder. And that's really important for high-powered engines, because high-powered engines, you're looking to make as much power as possible, you're packing a ton of heat in here, and that heat can lead to knock. So the hotter your temperatures within the cylinders, the more likely you are to run into knock. Knock basically is when you have combustion occurring that isn't ignited from your spark plug, and it can destroy engines, so you don't want it to occur. So by having that cooling effect, you reduce the temperatures, you reduce the likelihood for knock, and that means you can advance your spark timing and make loads of power. So that's a big advantage of direct injection. But direct injection is certainly not without its flaws. So because the components involved are seeing much higher pressures, a lot of them are going to be significantly more expensive. Also, because you're using higher pressures, you're going to have higher parasitic losses. You have to drive this high pressure fuel pump in order to make those really high pressures to inject the fuel into the cylinders. And of course, now that you don't have port injected fuel, you're not actually spraying any fuel onto these intake valves. So great, your air-fuel ratios are more precise. However, you don't have that cleaning power of the fuel to clean off these intake valves. Over time, depending on the design, that could mean having a buildup of carbon deposits within the intake. So then the obvious question is, well, why not both? And so that's actually what quite a few manufacturers have implemented. And there's a lot of good strategies that you can use by combining both port and direct injection. For example, at low loads and low RPM, use the port injection with or without direct injection so that you have a nice air-fuel mixture going into the cylinder. And then as you get to those higher RPMs and higher loads, you switch over to just direct injection. That way you have that cooling effect occur directly within the cylinder and you can maximize power potential. Another clever strategy is to use a stratified air-fuel mixture. So what does this mean? Well, let's say we're trying to operate as efficiently as possible. So what we do is we use our port injector, we spray some fuel in, but it's still running very lean. So the air-fuel mixture that ends up within the cylinder, there's more oxygen than there is fuel to burn. And so in order to ignite that lean air-fuel mixture, we spray a bit with the direct injector right beside our spark plug. So right beside the spark plug, there's a little pocket of rich air-fuel mixture, and then everywhere else, it's very lean. And so the spark plug ignites that rich air-fuel mixture, and then the rich air-fuel mixture ignites all of the lean air-fuel mixture. Lean combustion alone isn't very stable, but if you can start it off with that rich little pocket, then you can run a higher overall air-fuel ratio, meaning you can operate more efficiently and you can create the same amount of power using less fuel. How neat! Now, of course, by having those port injectors, you now have that tool once again to help keep those intake valves clean. And there you have it, the evolution of fuel injection. Big thank you to Advance Auto Parts for sponsoring the video. Of course, check out their link in the video description. And if you have any questions or comments, of course, feel free to leave those below. Thanks for watching.